All right, so for section 2.8, we have domain and range. Now, domain and range has to do with graphs, okay? So domain means, well, let me write it down. So let me give you guys this right here. So whenever we talk about domain, remember this all has to do with graphs. What they're talking about is, and I'm going to put this the easiest terms I can. Like there is a mathematical definition, but usually people are like, what? Right? So let me just put it in plain old English, right? How far left and how far right a graph goes. Okay? And in parentheses, I'm going to put right here x values. These are our x values. How far left, how far right a graph goes. Now, don't be fooled by the picture itself, okay? Because sometimes when they give you a picture, you're like, oh, well, they only graphed it from -3 to +3, so that's my domain. It only went that far. Remember, graphs go on forever, right? So you have to kind of imagine that this graph keeps going this way or maybe keeps going that way. So sometimes graphs, they just give you a picture because they have to fit the picture in the paper, right? But the graph can keep going, right? We draw lines and then we put little arrowheads on the edges, right? Why? Because those lines keep going forever, right? But we can't, I mean, there's no paper big enough to draw an actual line because the line is infinitely long, right? So domain, how far left and how far right a graph goes. So you're basically going to look at a picture and say, how far to the left is it going to go? How far to the right is it going to go? And that's what you're going to write for me, okay? Now, there's another thing called range, okay? So range is how low does it go to how high does it go? Okay, so how low and how high a graph goes. And lows and highs, these are y values. Okay, these are your y values. So again, you're just looking at a picture and you're going to ask yourself, okay, let me look at this picture. How low did it go? Okay, and then once you make your decision on that, how high did it go? And once you figure that out, then you're good. Okay, so domain and range is just, domain is how far left and how far right. Okay, range is how low to how high. And in that order, okay? Don't ever tell me how high it went to how low it went. That's going backwards. We're going bottom up, left to right. Okay? How low did it go? How high did it go? How far left? How far right? In that order, the way I wrote it. Okay? The reason is because they're going to want you to write stuff down in interval notation. Okay? So, let me give you an example of interval notation. Now I'm going to write it down really quick, and then I'm going to show you a picture. Now, by the way, just so you know, I'm going over the hard stuff first, and then we're going to do examples of stuff that's easier, and then we'll kind of do some examples of the stuff that's harder. But I just want to introduce it to you guys first. So interval notation. It's supposed to look like this, okay? A to B, all right? Or it can look like this, or like this, or like this. Now this is an interval. This means from A to B. Don't include A or B. So the parenthesis is kind of like a less than or greater than symbol where they're saying it cannot be included. A and B cannot be included. That's what a parenthesis does. But this is a range basically, okay? If I were to draw it, it would look like this, okay? That's what it would look like. Open circles. Everything in between is included, just not the endpoints. Okay? That's parenthesis A to B. Okay? From A to B, but A and B are not included. Now, the next one. From A to B, but B is included. So the bracket means include that number. So if I draw you a picture, it looks like this. Open on A, solid on B. Okay, so your intervals from A to B, but B is included. A is not, but B is included. The next one, from A to B, but A is included. And again, if we draw a picture, A will have a solid circle, and B will be an open circle. Has anybody here ever seen this notation? So, David, you've seen it. Anybody else? So, okay, Sonny. So, yeah, not too many. I'm kind of surprised because you guys are supposed to see this, heck, I think in like 8th grade for sure. But, I mean, then again, pandemic and all that stuff, who knows? Maybe some teachers just left it out. But, and then the last one, both are included. From A to B, both A and B are included. And the picture will be solid dots on both sides, okay? Now you're not going to have to draw these pictures. I'm just showing you the pictures so you can understand what we mean from A to B. Like it's a number line from here to here, excuse me, from here to here. And sometimes you include the endpoints, sometimes you only do one or the other, sometimes both, right? The notation itself tells you whether you should include it. A parenthesis means don't include it, and the brackets mean include it. Now, the hard part about this is you have to know, is this part right here, I'm going to kind of highlight it real quick, is this a point or an interval? How do you know? It depends on the question. If you're graphing points, then A comma B is a point, right? But if they're saying the domain is A comma B, that means that's your interval. So you got to make sure you understand that even though it looks like a point, the A comma B up there, it can reference an interval. It depends on what's happening, okay? So far we've covered domain, which means how far left does it go, how far right does it go. We've covered range, how low and how high does the graph go. And we've talked about how we're going to write the domains. We got to write them in interval notation from here to here, right? And even the range from here to here. We're going to use this notation. But before we get into that, we got to discuss how to tell if one of these graphs is a function. And it's really easy. It's called the vertical line test. Anybody ever heard of that? The vertical line test? So one, okay. And it's easy. It's really easy. So let me put this right here. How do I know if a graph is a function? Okay, so how do I know if a graph is a function? Use the vertical line test. Now the vertical line test is amazing. You just got to draw vertical lines, that's all. Okay? Let me show you how to use it. So by definition, if a vertical line touches the graph, so you're drawing one vertical line, if it touches it only once every time that you draw one, then it's a function. Okay, it can only touch once per vertical line. So let me show you what I'm talking about. Let's say I draw a graph that looks like this. and I tell you, is this a function? So this is what I'm going to do. I'm going to draw a vertical line here, 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 like all over. And you don't have to literally do it. You can just think about it. Okay? But I'm going to show you a picture here. Notice how every vertical line only touched the graph one time. You guys see that? It only touched once. Okay? I'll zoom in. It only touched one time per vertical line. Okay? The points, let me just kind of highlight them again. So they're right there. If that happens, then that blue graph, that is a function, right? So this would be a yes. If I asked you, like, is this a function? You would say, yes, it is. It's a function. Okay? Because it only got touched by vertical lines once. Now, I can draw you other pictures. What if I draw you a picture that looks like this? Would that one pass the vertical line test? Yeah, it would, right? Now, just to kind of double check, let me draw a couple of vertical lines. Did any of those lines ever touch the graph more than once per line? No, right? Look, there's a dot here, there, 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 and there. Only one time per line. So this would be a function. Okay, so if they ask you, is this a function? You're going to say yes. Is that one a function? Yes. What about if I draw you a picture like that? Now this is a graph of a circle. Is a circle considered a function? No, because if I draw a vertical line, let's say right here, notice it touches once and again. So this is a no, right? Let me do that in blue since I was doing it in blue. But this is a no. All right? So to test if something is a function, just do vertical lines. You don't have to physically draw them. You can just look at the graph and say, right about there, it's going to fail. So then, no. Or, yeah, if I go through everything, it's going to be okay. So, yes. All right? So, are we okay with how to tell if something is a function? So, if I were to draw you something like this, what would you say? Yes or no? No, right? This is a no because I could draw a ton of vertical lines. And each one of those touch more than once. Okay? Now, sometimes people say, yeah, but look, I drew a vertical line way in the front and it only touches one time. Well, true, but there are other lines that are going to fail. So as long as there's one failure, then it's not a function, okay? So this would be a no as well. So are we cool with how to tell if something's a function or not? All right, so let's go to, like I said, that was the easy stuff. You're going to have questions like this, I think 4 of them for sure, okay? You're going to have 12 problems. 4 of them are going to look like that. Now, let's go back to the interval notation and domain and range. So here we go. So here are example here. Find the domain and range. Now I'm going to draw some pictures. And they kind of have to be a little accurate, but not super accurate. But I'm going to try my best to not make them too complicated. So here's a picture of example 1, okay? So I'm going to put example number 1. All right. So this is a 3x3 graph here. All right. And I'm going to put a point right here. Now we don't know the function itself. We don't know what the equation is, and it doesn't matter. It doesn't matter. Okay? But just out of curiosity, would you say that this is a function, the red graph? No, right? Not a function, because you can draw a vertical line right through it towards the right side, and it's going to touch the red line twice per line, right? So not a function. But that's not what we're interested in. We need to know domain, and we need to know range. So, let me disconnect this thing really quick here. Hopefully it doesn't freak out. Good. Domain is how far left to how far right. So look at our picture. How far left does this graph reach? I mean, if you look at it, how far left is going to be at that red dot, right? That's how far to the left it can go. It can't go any further left than that red dot. What is the x value of that red dot? That's a positive 2, right? Positive 2 right here. So I'm going to say my domain is 2, comma. How far to the right is it going to go? Now remember, don't be tricked by, oh, the graph ended right here. These arrowheads means it keeps going. How far is it going to keep going? Forever. What do we call that? Infinity, right? By the way, on your quizzes, you literally have to type the word infinity, okay? So I'm gonna write it like this. Now, just so you know, infinity cannot be contained. It is a number that keeps growing forever. So it should always have a parenthesis next to it. Negative infinity and infinity should always have a parenthesis next to it. Did my graph include the number 2? X equal to 2? Does it include it? In other words, do you see a nice solid representation of the number 2 on it? Yeah, there's a dot there, right? So I'm going to use a bracket. So this is telling me, the domain is saying that my picture existed from x equal to 2 till forever, right? And there it is, from 2 and to the right, it just keeps getting drawn. All right? Any questions on the domain? From the left to the right, okay? Range, how low to how high? How low is this graph going to go? Because these are arrowheads, right? It's going to keep going down forever. Do you guys agree? Yeah. What does down forever mean? Negative infinity. All right? How far up is it going to go? Positive infinity. Can I put brackets, those square things, on infinities? No, because infinities cannot be contained. So here's your range. It goes down forever and up forever in terms of y. Okay? In terms of x's, it goes only as far as 2, but it keeps going to the right forever. Okay? This is the hard part that I'm telling you guys, domain and range. Okay? Where you kind of have to, notice I didn't do any work. I didn't like, oh, let me add 3, subtract this, divide by that, move the x. I didn't do any work. I'm just using my eyes and saying how far this way, how far this way, how low, how high. Okay? It does matter. Good question. Does it matter the order I put them in? Remember how I told you in the definition that it's important that you go left to right and bottom up, because you're going small number to big number, always. Smallest x to the biggest x. The smallest y to the bigger y. Okay? So it's very important you go left to right and bottom up. So thank you for that. Yeah. So very important that the order is kept. So let me draw another picture. By the way, I'm not doing any questions from your homework, because the homework isn't, I'm going to use air quotes here, but the homework isn't hard in the sense that you're doing all this crazy hard work where you're sweating, like you're observing. That's all you're doing. But I am doing questions that are similar to your homework, okay? So at least you'll have things that look very similar to it. So I'm going to do a parabola this time. So you did have a picture like number 1 there. But I just think practicing this is very important. I really don't want to take any of those from you. But that just means you have to actually do 12 problems. The good news is it's not a lot of work. actually, hold on. Let me use red just to keep things consistent. All right, now, just so you know, I didn't put this point there, okay? I didn't put any points on this one. But just so you know, my lowest point is at -1, -2. That's where I'm trying to make my lowest point, -1, -2. Okay? So if you want to draw it very much like me, it doesn't matter if yours don't arc perfectly like mine are, that's fine. It doesn't matter. Mine aren't even perfect, but it doesn't have to be perfectly the same shape, but something similar. Just make sure that your lowest point is at -1, -2 on your graph. Okay? Just out of curiosity, is this a function? Yes, this one's a function, right? You can draw vertical lines. Heck, if you look, you can see there's a bunch of little vertical lines that are already pre-drawn for us, right? And none of them touch the red graph more than once. So yes, it's a function. Now, domain. Okay, my domain. Let me write this out. Okay, domain is up, down, or left, right. What is it? Or down, up, left, right. Which one is it? Say it louder. Left, right. Okay, I'm going left to right. So, how far left does this graph go? Notice there are arrowheads here, right? So this is going to keep going up and to the left forever. So what do I put? It's going to the left forever. Say again. I think I'm hearing it. All right, so negative infinity. How far to the right is it going? Again, you got to try to imagine that this thing is going up and to the right forever, right? It's not stopping. So what do I put on the other side? What do I put for my x value for going forever to the right? Infinity, right? And remember, do not use brackets. You can only use these parentheses, okay? Because infinity is a number that grows theoretically forever and ever. You can't contain it. Once you contain it, it's no longer infinite. Now, range. How low does it go? What is the lowest y value that you see? -2, right? It's down right here. Right, -2. Right in this little area. So -2. How high does it go? I mean, would you say it goes up forever? So then we call that infinity, right? Remember, you're going to have to write that word out, okay? infinity, all right? Infinity. You could put minus infinity, like a negative infinity. That'd be okay, but they want you to write it out. Should I include -2? Like, is that y value there? I know they don't have a point there, but if you look at the graph, does it look like the graph includes the y value of -2? Let me zoom in really quick. Does it look like it's included? Like, could I put a dot right there, like that? Yeah, right, it's there. There's no hole. If there was a hole, like you'd see like an empty thing like that, right? Then you'd say, oh yeah, it's not included. But there is no hole in this one. It is there. So include it, okay? It is included. Just because there's no dot doesn't mean it's not part of it, because sometimes there's not a dot in the graph, but you look at the graph and you're like, yeah, it passed right through it, so it should be okay. All right? So there's your range. We're going to do one more of these things, okay? Let me see if there's one that's like really weird here. Well, this one's not too bad. We're going to do one that's a circle. Let's do a circle. Let me draw this out for us really quick. Give me a second. Example number 3. And I'm going to draw a graph for us really quick. I think I made this one 4 by 4, just a little bigger, just so I can draw a decent circle. Now I am going to cheat here. My apologies, but I can use a tool that'll draw me a decent circle, so there you go. So let me put that up. This circle has a radius of 3, so it goes 3 to the right, 3 up, 3 left, 3 down. Okay? Drawing a circle is always tough. Domain and range. Is this a function? No, right? Not a function. Because of the fact that you draw a vertical line, you're going to get it more than once, right? More than once. So not a function. So we're kind of practicing the first couple questions at the same time as we're doing these. Now, my domain. How far left does this graph go? -3. How far to the right? +3. So -3 to 3, you say, right? -3 to 3. Should I include those numbers? Are they part of the graph? Like, did they cross right through 3? -3, I mean? Yeah, right? And does it cross through +3? Yeah, it does. So I'm going to put brackets. Okay? I'm going to put brackets. All right. My range. How low does it go? -3. How high does it go? So basically, it's the same thing here, right? It's the same thing. Just to remember, these are the domain are my x values, and the range are my y values, right? So I'm going to put -3 to 3 because it does include those numbers as well. Okay? So this is what your homework is, guys. The first 4 questions, so I think it's going to mix them up for everybody, just so you know. I don't think you're all going to do the same first question. Well, maybe a couple, but not many. But it's going to mix it up for you guys. But there's going to be like 4 questions that just ask you, are these functions? So you just kind of do the vertical line test, kind of eyeball it. And you're going to, I think, either choose yes or no, or maybe you type yes or no. And then the other parts are going to give you a picture, and they're going to say, give us domain and range. And just so you know, I'm going to let you do this assignment an infinite number of times. So if you mess up and you don't like your score, you can do it again. I think it'll tell you which ones you missed. That way at least you know which ones you have to fix. Okay? So just so you guys are aware.